My name is Norbert Sram. As you can see, there's no company affiliation or anything listed there. That's intentional. This evening, I'm only here because of my love and hate towards JavaScript. As to which is more powerful, I'm still undecided, but I'm getting there. Topic, TypeScript. If you don't know what TypeScript is, I copied, actually screenshotted, whatever, the official site. It says that, yeah, you can read it. The important part are highlight types. That's like if you say types in JavaScript community, then people start coming with a pitchfork that who needs types. So just bear with me. My goal here is not to start another religious war about dynamic versus static or strongly typed and so forth languages. Rather, I just want to communicate 1.5 aspects to you guys, and I hope that you will find that useful. And the first aspect I will share shortly. Let's move on. Some type theory. So if you want to classify languages, then if we simplify it, so let's not go into nitty-gritty details, but roughly I would say you can have, based on the type assertion, coercion, it can be either or actually when you do the type checking and assertion, it can be either at runtime or at compile time. That's like the two big. And when it comes to how interchangeable types are, again, it can be very interchangeable, yay, JavaScript, or not so much at all. If we sprinkle some mainstream languages here, you will roughly see the categories. I mean, I assume that everybody did, I don't know, JavaScript, hopefully to some degree. Then you are familiar with its nature, that I can just say, yeah, here is a string like number 2, and here's a number 2. I can add them together. JavaScript is happy. What's the result? Are you sure about that? Exactly, that's JavaScript for you. I'm not going to give you the answer because I don't know either.
What was the question?
So too late, we move on. Okay, so there's JavaScript, and today we are talking about TypeScript, and that's essentially this. So it moves JavaScript to the above and beyond. Very good, very good. I'm going to coin that term, thank you. So above and beyond, that's for the camera as well, just so I don't forget. That's kind of the idea. Yes, it's optional. You know, it's not mandatory that I sprinkle and type annotations everywhere, but you get the idea. Why it's next to C# or below Haskell, let's not get into those details. It's just randomly placed there. So no discussion about that. But enough theory. Let's start to kind of get into a bit of practical details. Who doesn't know the rules of chess? Don't be shy. I can skip the next section. So this is a chessboard. That's a horse. I mean a knight there. And if I want to move that piece on the board, I can easily move it in an L shape, right? So that's a valid move. Everyone agrees with that. It's there. Let's try something different. I want to move it there. That's a no-go. That's like beep, validation error. We can't do that. So this is something we would like to model now with, let's start first with JavaScript. So I would say what I really like about JavaScript and hate is that it's very simple. I mean, you want to keep it simple. Well, what's a move? Where it's an object or a tuple or whatever you want to call it. There's a from part. There's a to part. These are coordinates. Yeah, let's just put it in a string because strings are good for everything. And done. That's my move. And I want to add some logic to it. So how is the chess game? Well, I have to validate whether the move is valid. We saw that before, that it's possible that the user unintentionally enters something that's not correct. That never happened before, but this is a hypothetical scenario. We have to check for that. And of course, whether the game is over, right? So one potential simplified case is that it's a checkmate for the player based on that win, so it's over. What I roughly talked about is this part. So we do a checking. Yeah, bad move, not going to work. Result is undefined. That's a homework for you. But that's roughly how you would do it in JavaScript. Straightforward, simple, we can make it better. Yes, board state is coming from a magical closure. Not important right now, roughly followable. Okay, everyone agrees? How do we do it in TypeScript? Well, the previous one was that's actually valid TypeScript as well, right? It works, but that's not our goal here. And this is where I would say introduce my main goal for this evening. Type systems are as good as you make them to be. So whether a type system is helpful or ends up adding value to your work, it really depends on you. You have to put in the effort, and whether that effort pays off or not, it's hard to judge. This is why we have like dozens and dozens of research topics about the trade-offs of type systems. People tend to argue that you have the same amount of bugs with static, strong typing. So why is beneficial? But let's approach it with more of a type-driven design. So we are not going to talk about the concrete implementations. We are going to introduce the states with types that our game or our move might have, and how we can transfer those states. If you want to go very mathematical, it's really an algebra for the chess. If you want to have more computer science view, it's a finite state machine that you kind of define through types. But we can agree that there's an unchecked move, which we get from user input, for example, and there's a move, or we can also call it checked move, which is verified that it's correct for a given state. That is a valid chess move. So we differentiate between the two kinds of moves. The next important step is how you define your logic. You actually need a function that transforms from one type, unchecked move, to a type of checked move. And actually, if you design it properly, this should be the only way to create an instance of a move, meaning a check move. There's no other way. And this comes down to an assumption that's formally verified, checked for you during compile time, that yes, your program is assuming some behavior, some state, which is verified through compilation steps, thanks to how you define your types. If I move forward, as I said, I could just read a move from the user. I know that it's an unchecked move because I have not yet done any verification. I did not pass it to the isValid move, which is the only way to create a checked move out of an unchecked move. And then the best part is this. If I forget about that, the compiler will warn me that, hey dude, that's a no-go. There's a magical type issue message here. That's not the part. The important part is that there's a yellow box and the red wiggly line under move that you're doing bad things. That's really important. It happens to everyone, and it happens to all of us. But this way, as your application scales, you can make assumptions, you can do separation of concerns, that my chess engine only works with valid moves. I don't care about how a move is validated, but I'm 100% sure that when I get a move, it's valid. And that's encoded in the type system. This is why I said that it's really, end of the day, up to you how beneficial it is for you or not. I know, this is the usual, yeah, this is a magical example that I don't do on a daily basis. So let's drill into a kind of specific problem. I would say my usual go at this is that scratch your own itch. So I tend to travel outside of the borders of this magical country. And if you do that, sometimes there are queues at the borders. And there's this awesome website which you can use to actually gauge what the status is. So you might be asking, what does this website do? Well, it supposedly gives you real-time guesstimates because it doesn't reflect at all the reality, but you can, if it says 1 hour, that's between 1 hour and 2 hours, roughly. But you get the idea. And you might be asking, but this is like, I'm talking in English. Why isn't there like an English screenshot? Well, that's one of the missing features. There's no, there's no English translation for this. So that's also on the to-do list. I actually found out when I was putting this slide together, I'm going to go English, and there's like the menu is hidden away, that there's no longer border traffic information, and you have to kind of live with this one. Yeah, so but I'm not going to bash this anymore. Our goal is to really roughly create a crawler for this site that fetches the data and stores it in JSON format, so I can have fun with charting historical traffic information and do another meetup talk about machine learning and border traffic in JavaScript. You're laughing now, but I'm going to do it. I'm going to do that. Just so yeah. Let's start the actual project. Disclaimer, we don't have time to go through the whole thing, but it's up on GitHub. Feel free to contribute. I don't want to do all the work, so I'm happy. How do you create a new JavaScript? We all know how do we create a new JavaScript project. Copy paste some starter. But how do we create a new TypeScript project? The compiler has an init call, and that just dumps some configuration files for you. Has some magic in it. Who actually uses TypeScript? Nice. Who uses it because of Angular? Same people. Shocking. Angular has a different set of base rules. So this is the other thing to remember from this talk. You want to make sure that strict is true. Remember that. If you're going to do TypeScript, then punish yourself. That's the best feature ever out there. It's listed what it actually includes, and the TypeScript team actually recommends this setting. It becomes really like, I have to use PC words, so it's really strict language after this. But yes, please, if you're starting a new project, please, even if it's an Angular one, turn it on. You will thank me after some hate mails. At one point you will say, well, it's not that bad. I got used to it. The other awesome feature, strict null checks. Who had in their development career, especially as a JavaScript developer, the error message that undefined is not a function, or undefined does not have property, whatever. No, exactly. Well, I'm not.
Since proxy object, you know.
Yes, silver bullet proxies. But yeah, I mean, for some of us who are not yet masters of proxy, I sometimes have that message like undefined is not a function. I'm not ashamed to admit it.
Message, you know?
Yeah, it's like giving you some rough ideas that, oh fuck, I forgot something. So that in TypeScript, as I said, that's like number, that's how you declare a type, you guys know it. And what's the awesome feature? This is in strict mode. So what I'm going to talk about now is TypeScript in strict mode. Any other mode is non-existent. And in strict mode, it will tell you that, hey, that's a number. You're not going to assign null to a number. And even if I remove the type annotation, type inference will say that that's a number, that's not number undefined null, that's a number. Same error. The only way you can tell the compiler, chill, I want that null there, is that you have to explicitly annotate the type accordingly. So you say that some number, it's either a number or null. Those two are the possible scenarios. In hindsight, what I forgot to put here is that, yes, I can assign number now, but what TypeScript will do for you, if I want to dereference some number that, hey, I want to get the value from the number, TypeScript will tell me that at this point in the line of code, it's either number or null. You have to verify that it's not null before you can actually dereference and get a number from it. Otherwise, it won't compile. Otherwise, it says that you're cheating and lying. And the compiler is right. That's really an awesome feature. There's a reason it's called $1 billion mistake, nulls in language design. Here's the reference. I'm not going to read it. But that's really one of the top reasons nowadays, even in Java, JavaScript, that null pointer exception, whatnot. It's like, yeah, usual. When there are surveys, what's the most frequently thrown error in Java? Null pointer exception. Most frequent error in JavaScript. Guess what? So yes, that's the power of strict TypeScript. And you see that number or null, that's actually a union type. So if we go back to our example of border traffic monitoring, on the police.hu site, there's a certain amount of countries listed where you can get the traffic. We can declare those as a union of strings. So we say these are the countries where we can crawl the data from that website. And if I want to actually get a URL, which I can then call with curl or whatever to get the data, I have to pass in like the country string. So one of the magical strings from there. And that's like a common pattern we do in JavaScript as well. If I just take Redux, React, Actions, they usually have a string identifier. Well, TypeScript is again here to help you out, because if it's not in that type union, like I want to get the police.hu entry for USA because we all know that I can just drive to USA from Hungary by leaving the borders, TypeScript will tell me that, well, that's not going to work out for you. So that there's no type for that country. You are only allowed to pass a value from that union of values. The other interesting aspect here is that I'm so positively kind of going into an object and saying, hey, I'm sure that there's an entry for that key passed through the function. What can go wrong? I mean, I get a string. I'm sure that there's a correct value in my magical object for that particular key. It's not going to return undefined. It's going to return a value for me. It's going to return an URL string. The reason I'm sure about that is again due to how you define your types. Now my magical lookup table is actually declared that it must have a key for all country entries. If one does not exist because I decide to delete it, or let's assume that a new border crossing gets data entry because of political reasons. Let's not go in that round. But yeah, you can imagine the situation. TypeScript will tell me that I see what you are doing there, and shame on you. Because from this point on, it will tell the developer that you are no longer declaring a value for all possible types. The power of this really comes across because I'm using this for the crawling part. I'm using these domain definitions for the front-end part. If I change it one place, so if I change the original definition and remove a country or other country, I get a list of errors as to where I need to adjust my code because of these scenarios. And that's given to you at compile time due to how you define the types that you use. This is just like a basic map type example. There are tons of things you can do, but we don't have time for that, unfortunately. The most important aspect of TypeScript is still, I would say, interfaces. Forget about classes. Classes are for Java developers. Interfaces, that's all you need. If you check out the TypeScript compiler code base, you will see that there's not a single class declaration inside it. Not a single one in a compiler. They use interfaces and TypeScript in a strict mode. Interface is basically a schema for an object. So if you check here, I just say that, hey, there's a JavaScript object. It has those properties with these kinds of values. If I want to instantiate something, I just do it this way. Actually, I could even remove the type annotation from the instance, would work. Again, if I delete a value, it means that it's no longer a queue time, because a queue time has all three entries. Why? Because there's three kinds of traffic stops on each border. There's a different queue for cars, there's a different queue for commercial trucks, and there's a different queue for buses. And our domain and our type definitions reflect that perfectly and accurately. As to why I would define time and queue in strings, well, ask polit.hu, because the queue can be 1 óra or 3/4 óra, as you would expect from any sane website. Good. This is also an awesome part of TypeScript. There's a bunch of type helpers defined in the core library of TypeScript. So there's more than a dozen. There you have partial, and I forgot the rest. So, but trust my word, click this link.
You're a developer.
Yeah, exactly. There's also read-only, which I used on the previous slide. There you see that. So there's a bunch of types. Why this is important is it can happen that there's a situation that, hey, I only need some fields from this object, not the whole thing. There's also a type for that. Like if Lodash has these that extract a certain set of properties from an object, there's a type definition for that. And this gives you the possibility to always start with strict definitions. So I start with the strictest possible definition for my domain types. And then I start kind of, okay, here I can live with a partial one. I might not have a car or truck or whatever, but the compiler will force me to test that. It won't forget. I will, but the compiler won't forget that. And that means that I'm safe. And I can just assign a queue time to a partial queue time. Those are two different types. Partial has a simple definition. A bit cryptic, but simple. Essentially what it does is it iterates through the types, your types properties, and assigns a question mark to each one. A question mark in TypeScript means it's optional. So it can be either a string in this case, null or undefined. Essentially, it generates a union type for you that you don't have to write out yourself. The other topic that I haven't touched upon in the beginning, but I think it's worth noting, is that TypeScript uses structural typing. Who used the language with structural typing before? Exactly, it's not that common as you would think. Yeah, Haskell does it, Scala does it, magical functional programming languages do it. So Go does it as well. In JavaScript, we just call that duck typing. Structural typing is a fancy term for that in type systems. What this means is if I have a queue and I have some vehicle colors, I can easily assign a queue to vehicles. Why? Because they have the same properties. A type is defined based on its properties, not by its name. That would be nominal typing. That's what Java and C# does, for example. If in Java I declare a class person, I declare a class chair. If they both have a color, that's racist. If they both have a color, you cannot just assign one to the other because those are different types. Flow, the other TypeScript solution for typing, Flow actually has nominal and structural typing both. So if you declare a class that uses nominal typing, if you declare an interface that uses structural typing. And that's something that's important to keep in mind. And how you can work around this is what I showed you earlier, that you tag each interface. Like you say the type, give it a string, or type just some magical property with any type. You can do those. The TypeScript compiler does exactly the same thing to avoid those conversions that you not want to happen. But that's the solution to it. Once you get used to it, that you're aware of this, you can think about it as limitations or flexibility. I don't want to go into this, but
vehicle will not be equal to Q. Oh, vehicle will not be equal to Q.
Yes, that works. Yes, it does. That's structural typing for you. Test it. Feel free to try it out.
If I'm creating a new instance,
you can create a new instance of interface because the compiler will tell you that it's used as a type, whereas it's on the it's used as a value, whereas it is a type.
I mean JavaScript, not TypeScript. So if
No,
I'm
no,
creating a new object with car, bus, and truck, it will not be equal.
That's assignment. That's no. I assign it to vehicle. It's not equality check.
Oh.
I just assign it. We're not talking of the same thing.
Sorry.
So here we are just saying that a type, if a reference has a type of Q, I can assign vehicle colors to it because both types are defined by the same set of properties. And that's why it works. And yes, this is why I brought this up, because this is something that might trick you if you start using interfaces a bit much, but that's also a cool feature. Now, as I said, two main takeaways. Who uses strict mode now? You're my man. All of you should use strict mode. And the other thing is, before you go into the whole language wars on dynamic, static, strong typing, it's end of the day, it's really about you, the developer. It gives you the power that you put into it. If you just sprinkling some types, not thinking about the relationship between the types, how I can enforce some topics, then it's not going to help you that much. And there's really an awesome page on TypeScript website. It's called Advanced Types. I would really recommend everyone to read that a couple of times. There's a lot of material there. It's dense, but it's extremely useful. And the other thing, what is actually difficult with TypeScript, and you will bump into that especially in strict mode, is that type declaration files are buggy sometimes and are not well defined. So sometimes you're like, well, why isn't this working? Because of the lacking definition of the typings file. So again, there you bump into the same issues, and strict mode can be really, really annoying there. And then your best friend will be double type assertion as something, but you don't want to do that. And I know that this is a controversial topic, and especially in the JavaScript community, where we say that dynamic is the best thing ever. But there's also an increasing trend, as you can see, on the adaptation and the happy users of TypeScript. And actually, last year, almost 50% of NPM modules were written in TypeScript. Babel also supports now TypeScript. Jest is rewriting, the Jest team is rewriting their own library, which is Facebook developed. They should be writing it in Flow. No, they are rewriting it in TypeScript. So I think it's safe to say now that TypeScript is here to stay, and it's really an awesome language, and you should learn it. And that would be it for my side. Thank you for your attention. There's also a bunch of links. Questions? Yes?
So, you mentioned flow a few times. What's your opinion on flow?
So what's my opinion on flow? I would say that the type inference of flow is still so automatically deducing what kind of types a variable might have is still better, stronger in flow. But to be honest, I would not use flow at this point. The community support is completely lacking compared to TypeScript. So if you just check the number of typings you can find on GitHub, it's 10% of what TypeScript gives you. IDE support, it's night and day between Flow and TypeScript. You have Visual Studio Code, WebStorm, both of them have awesome TypeScript support. There's a TypeScript language protocol support. You can use it in Emacs, VI. So at this point, I would say it's fair to say that TypeScript won. That's my opinion on it. Yes?
I think it's winning because of Microsoft support. TypeScript has been made by Microsoft actually, and the Visual Studio Code also.
Good point. So what was mentioned is that TypeScript is winning because of Microsoft support. I would say that's a strawman's argument because Flow is developed by Facebook. We can safely say that both of them are tech giants. What's also a major difference, if you go to GitHub, open TypeScript GitHub project, open the Flow GitHub project, TypeScript is extremely open. You can contribute to it. You can open issues. Andreas Helsberg, the main designer, will answer you. You can contribute, while Flow is really internal focus developed in Facebook. Yes, they upload the sources, but the community is not involved to that degree. And in my opinion, that also is also an important aspect in this choice of the community. The other thing is TypeScript is written in TypeScript. If you start using TypeScript, you're already familiar with it. While Flow is written in OCaml. That's not the most widely used functional programming language. Yes, it's an awesome language, but Haskell or Scala are a lot more popular compared to OCaml. So finding OCaml developers who will contribute in their spare time is negligible compared to TypeScript. Any other questions? Yes?
Do you also see an increase of TypeScript usage in particular areas? Like sometimes you hear people say that people in the finance industry really love the more typing, the better. Do you know something about that in TypeScript?
So the question is whether there are specific domains where TypeScript usage excels compared to others. Unfortunately, I don't really know. I cannot give you any information on that. I think that the two main drivers here are Angular. So when you brought it, yeah, I'm working with TypeScript, you're working with Angular. The other aspect, I think, what's really a big driver is library developers. That would be the second big driver. So yes, we could say that most likely financial institutions use TypeScript because those are enterprises. Enterprises have a history with Angular. That goes hand in hand. But that's just my observation. It's not based on facts. Would you like to say something, Zoe?
No.
No, here's a good example of how a community should work. He raises his concerns, questions, so we appreciate that. And he's here every time we have a meetup. So we love Zoli. We like Zoli. Other questions? But we also love you guys, so let's start with you.
Why did you leave Slovakia and Slovenia?
Good question. Good question. I expected that question. Nice observation. I'm not the one who left it out. Go to police.hu. I'm only crawling the data that's present on that site. I'm just a messenger here. The other question?
I think that when look at the polymer, why it has been created, polymer, why it has been created. It has been created because the Google is trying to test features, and after that including to the JavaScript part, the native part. I think the TypeScript is more, some features from the TypeScript will be moving to the JavaScript side also. And there is a specific feature of JavaScript which is coming, I think, in the next months, is the call instance, which is coming from Swift programming language, and it's really useful for checking the nulls. It's because it's using some sort of you don't need to check whether your method is undefined or not. It's inherited in the language.
Yeah, I mean, essentially, yeah, that's a good point. Most likely it will end up in TypeScript as well because of the superset nature. So the question mark dot operator, but that's again syntactic sugar for doing if it's not null, then I do it, otherwise I don't. While that's again shorthand, quick hack, while what I showed you is intentional, designed, and well thought through decision. There's a big difference. I usually, when I do code reviews and I see that there's like a question mark there, I immediately go, what did you do? Why is the question mark there? Have you thought it through? Especially my favorite is when it has a type of array or undefined. Why would you do an undefined array? Empty array is not good enough for you. So these are the topics. But yeah, regarding to Google and pushing stuff into the specification, that's politics. I'm not going to go into that because it's being recorded. I have my opinions. I don't like Google. I use Firefox, and you should also. But that's it. I think that they also do contribute a lot to the JavaScript community. Just check V8, and I also really like their web developer blog posts. Those are awesome. But trade-offs. They have their own agenda as well, and they have to earn money. Any more questions? 3, 2. So thank you for your attention again. I will share the slides and then go quick.